Hi, Intermediate Algebra. This is Professor Wieland. I want to go over 10.5, which is quadratic functions. I was hoping to get this to you earlier, but I guess it just is what it is. So thank you for your patience with me. So quadratic functions are when you're graphing something that's second degree. If you're graphing something that's second degree, it's going to look like this. Okay, so any second degree function looks like this. This graph could be flipped or stretched, but this is the general shape. Okay, we don't call this we don't call this a quadratic when we draw it. We actually call it a parabola. It's sort of like its nickname. Instead of saying I draw a quadratic, you'd say I drew a parabola. Okay, so these graphs look like horseshoes. I want to start with showing you something called vertex form of a parabola. Let me say vertex form of a quadratic equation. Okay, vertex form of a quadratic equation, it looks like this. And the vertex itself is HK. So this gets a little tricky because it has to be the opposite sign of the inside, same sign as the outside. So let me show you what I mean. Let me give you a specific example. Okay, so here's a specific example. The vertex of this is going to be the opposite of this. Since this is -4, it's +4. And since this is +5, it's +5. So the vertex is at 4, 5. So I'm going to say that again. It's the opposite sign of the inside. It's the same sign as the outside. All right, let me just do one more. Alright, so the vertex of this one will be -7, -3. So again, it's the opposite sign of the inside, same sign as the outside. Okay, so let's talk about the formula a little bit. This formula right here, I'll just rewrite it on another page, and let me just give you some then notes. Let me give you some notes on it so you understand how it works. Okay, the K on the end is what we call the vertical shift or vertical translation. If it's a positive K, it goes up. If it's a negative K, the graph goes down. Okay, so if it's a positive K, the parabola goes up. If it's a negative K, the parabola goes down. Let's talk about this part in here. This is the horizontal shift. So this is your left, right, left, right. If it's a negative H, it actually goes to the right. If it's a positive number, it actually goes to the left. So that confuses people when they first learn that, but try to learn that as soon as you can, because all graphs follow that rule. All graphs follow that rule. And inside of a radical, if it's negative, it's moving to the right. And inside of a cube function, if it's negative, it's moving to the right. Inside of a rational function, if it's negative inside, it's moving to the right. So all the functions follow these rules. We're just specifically applying them to a parabola right now, but the sooner you can learn these rules, the better, because these rules apply to like over 5,000 applications, right? 5,000 is actually a really tiny number. This applies to all of them, right? So an enormous amount of problems have this rule. All right, this guy on the front does two things. If this guy is positive, it's face up. If this guy is negative, it's face down. Okay, let's talk about if A is greater than 1. I'll just put in absolute values because it could be like -3 or +3. Or if this value is less than 1. And again, I'm just putting it in positive and absolute values because I'm not saying it doesn't matter whether it's face up or face down. It's the same. What it does is consistent for both cases. All right, let me give an analogy because it helps people. So this is going to be my analogy. I'm going to one time put a 3 in front of a quadratic, and another time I'm going to put a 1/3 in front of the quadratic. So this is just to help you. This is just an analogy. Let's say you go to the bank and you give the teller $100. She's going to put 3 times that amount in your bank account. Do you like her? Okay, probably yes, right? Would you say your account is going to grow faster or slower than it would have otherwise? Now, hopefully you're thinking faster. And what it looks like when something is growing faster, it means for just a tiny bit of input, just a tiny bit of input, a tiny bit of X, it's going to shoot right up. It's going to just shoot right up because it's got a lot of bang for the buck, right? A little bit of input, it can become very vertical fast. All right, now let's think of a different case. Let's say you give the teller $100 and she only puts 1/3 of that in your account, right? So you give her $100 and she puts like $33 and change in your account, right? So would you say if she does that every time you give her money, would your account grow slower or faster, right? It would grow slower because she's hampering your ability to accumulate money. So what that looks like graphically is that looks wide. Because you're giving her money, but she's only putting 1/3 in. So it's like taking a while for it to accumulate, okay? So when you put something less than 1 in the front, it makes it harder for it to get some speed, for it to get some height. Whereas if you put something greater than 1 in front, then you're pushing it up a lot faster. It gets a lot of speed faster and the function shoots up. All right, so let's put that, let me put it with the rule now. So greater than 1 would be the example I just did where you have y equals to 3x squared. What that does to your graph is it's going to make it narrow. It's going to be narrow. Okay, and if that value in front is less than 1, the example I just did was y equals to 1/3 x squared. What's going to happen to that graph is it's going to end up being wide because it needs a lot of input to get some height. Okay, gang, this was just sort of me going over the basics. We'll come back. You need to be able to graph. This section is all about graphing, so I just wanted to cover the rules here. Let me not make this video too long. I'll catch you again in another video. Bye-bye.